So the next 4 videos I'm hoping are going to be about derivatives, differentiation, the definition for derivative, and so on and so forth. And so that's going to hopefully be the next 4 videos in this series. So let's start on page 119 in the book, which can be found in the description, and see how many problems we have to do. I think most of these problems are for the secant line, just to have a small intuition for where we're trying to go to. I'll explain a little bit about secant lines and derivatives. I'm not going to actually take any secant lines, I hope. Anyway, we'll see. So you can have a function goes something like this, and you can find the slope between 2 lines. So let's see this point and this point, and you want to know how much things change. You know what, let's make the function more dramatic. So let's say you have a function like this. You want to find the slope between this point and this point. So you want to find a line that intersects both of these points, right? So you need to find, and specifically you want to find the slope of this line. So you can take point, let's say this is point P, and this is point Q. So you can take point P as x1, comma y, x1, comma y1, and then point Q is, let's say, x2, comma y2. And in order to find the slope, we do rise over run, right? The change in y, how much y changed over how much x changed, which over here is going to be y2 minus y1 over x2 minus x1. And this is m. This is our slope. So now we can start to think about not a secant line. So again, we're going to have this, and we have our secant line, which is this. But we want maybe to think about a line that just touches this point. It doesn't touch any other point. It kind of just only touches this point, and we want to think about the slope of this line, a line that goes and just touches the single point and doesn't touch anything else in the graph. Well, we can think about this line as, I'm going to start using colors, why not, as different colors, as a bunch of, oh, that didn't work. Okay, let's start over. So again, what we have is we have our graph, and we have a secant line between 2 points. So here we have 2 points. We want to find a tangent line between these points. So we want to find a point that just touches this point and does not touch any other point. So we can think about it in terms of a bunch of secant lines going to this point, maybe that, and then I'm just going to stick to green. So a bunch of secant lines that slowly get closer and closer to this point until they become this tangent line. Or in other words, what we can do is we know what a slope is, and the slope of any for secant lines, we have that a slope between 2 points is going to be, so let's take f of x equals y, and we're going to have 2 points P, which is going to be the point x1, y1, and Q, which is the point x2, y2. But we can also write this in terms of x1 and f of x1, right, because that's what y is, and we can write this in terms of x1, x2, and f x2 x2 and f of x2, right? And then when we take, so to find the secant line between these 2 points, we need to take f of x2 minus f of x1, and this is right here, the rise. This is delta y is equal to this, and then over delta x, well, that's going to be divided by x2 minus x1, right? So let's look at that. So now let's try to find our tangent line. So we're going to make the points over here 1 point closer and closer to the point where we want to find our tangent line. So that's going to be, let's take the limit as delta goes to 0 of delta y over delta x. Let's just call this dy over dx. And what is this? So we know that delta y over delta x is equal, and we want the change to go to 0, the change between for y and for x. So this is just going to be f of x2 minus f of x1 over x2 minus x1. So the limit, if we want the change to be up here to be going to 0, and we want the change down here to be going to 0, what we have to do is we have to let's say x2 go to x1. So we have to take the limit as x2 goes to x1 of f of x2 minus f of x1 over x2 minus x1, or what we can say is just take the limit as x goes to a of f of x minus f of a over x minus a. So we're approaching the point A and we're finding the tangent line. This way we're finding the tangent line to the point A. And sometimes we write this in terms of the limit as h goes to 0 of f of x plus h. Well, so for a given point x will equal a, and for any point x is just going to be x plus h minus f of x over h. So over here we're going to 0, and over here as h goes to 0 we're also going to 0. So that's the idea behind the derivative. So in this section we are going to look at the notion of a secant line and maybe perhaps understand it a little bit more. I'm not going to spend that much time, I guess, with the secant line. So a curve has the equation f. So this is the first problem. A curve has the equation y equals f of x. So that's our equation. Write an expression for the slope of the secant line through the points 3 and f of 3. So we have a point which is 3 comma f of 3, and q, which is another point, x comma f of x. So q can be some arbitrary point, and then so write an expression for the slope, and then write an expression for the slope of the tangent line at P. So the slope for the secant line at P is going to be f of x, right, minus f of 3 over x minus 3, because this is the change in y and this is the change in x, right? The change in y is f of x, right? So have something like this, and here is our x, and here is our 3, and here is our f of 3. Here's our f of 3. Here's our point P, and here's our point Q. And in order to find the slope, you want to find the difference between f of x, the difference between f of x and f of 3. So that's this. This is delta y. So that becomes f of x minus f of 3, right? That's how far you have to walk until you get to f of 3 from f of x. And then you want to find the difference between 3 and x, which is x minus 3, right? How long do you have to walk from x until you get to 3? You have to walk a distance of x minus 3. So that's the slope. And then if you want to find the tangent slope, you're going to take the limit as x goes to 3 of f of x minus f of 3 over x minus 3. Because now x is getting closer and closer to 3 until it pretty much becomes 3, and we're finding a tangent line to f of 3, which is right there. So that's the solution to problem 1. We're not going to do problem 2 because that requires a graphing. Let's look at problem 3. So let's find the slope of the tangent line to the parabola. So we have f of x equals 4x minus x squared. And we're looking for the slope of the tangent line at the point 1, 3. And we're going to try to do this in 2 ways. First one is using definition 1. So definition 1 says m is equal, so the slope of the tangent line to a curve is equal to the limit as x goes to a f of x minus f of a over x minus a. So for us, this is going to be the limit as x goes to, and over here, so for a given point, a is going to look something like this. This is the definition. So for us, our a is 1. So it's going to be, as x goes to 1, f of x minus f of 1, which is 3, minus 3, over x minus 1. This is going to be our tangent slope, or in other words, it's going to be the limit as x goes to 1, and f of x is 4x minus x squared, then minus 3 over x minus 1, which is equal to negative x squared plus 4x minus 3 over x minus 1. And we can write this in terms of, let's see, negative x, and then we want to know times what is going, and then right over here we're assuming we're going to have x minus 1 because we want everything to cancel. So you're going to have over here negative x squared plus x, and so we want 3 more x's, so over here we should have a plus 3, and then we're going to have plus 3, and then minus 3, so that works out. So this is equal to that. So let's just write this all out again. So right, we're looking for the limit as x goes to 1 of limit as x goes to 1 of negative x squared plus 4x, negative x squared plus 4x minus 3 over x minus 1, x minus 1. And we can say that this is going to equal to the limit as x goes to 1 of negative x plus 3, negative x plus 3 times x minus 1 over x minus 1. These cancel, so this is going to equal to the limit as x goes to 1 of negative x plus 3, or in other words, it's going to equal to 2. So m, the slope of our tangent line, is going to be 2. So that's finding using definition 1, and now part 2 says find it using equation 1. So what does equation 1 tell us? We have definition 1. Okay, so equation 1 does the same exact thing, just with the second definition that I mentioned, which is the h. So let's actually a new page, and now the slope in equation 2 is defined as the limit as h goes to 0 of f of a plus h minus f of a over h. So for us we have that a is 1 and f is 4x minus, so for us this is equal to the limit as h goes to 0. This is going to be 4 times 1 plus h minus 1 plus h squared minus 1 plus h squared minus 3, because we know what f of a is, over h, right? So this is equal, so this is becomes 4 plus h, the limit as h goes to 0, 4 plus h minus, so then we have h plus 1 times h plus 1 is equal to h squared plus 2h plus 1. So it becomes minus h squared minus 2h minus 1 minus 3. So 4 minus 1 minus 3. So these, we can get rid of that. and then, sorry, this over here we have 4h, so we have 4h minus 2h, so this is equal to the limit as h goes to 0 of negative h squared, down here we have an h, negative h squared plus 2h over h. And this is equal to the limit as h goes to 0 of h minus h plus 2 over h. These h's cancel, and as h goes to 0, this becomes 2. So from both the definition and equation 2, we get the same exact answer, that our slope, or our m, is equal to 2. So now we want to find the equation of the tangent line to our point, right? So we know that for a to find the equation for any line, we're going to have y1 or 2 minus y2 equals m x1 minus x2. And for us our m is 2, and let's just pick up, well, for us the point is going to be 1 and 3, so it's going to be y minus 3 is equal to 2 times 1 minus x, or in other words this is 2 times x minus 1, because it's the x2 and the y2 that we're plugging this into. So then this becomes y minus 3 is equal to 2x minus 2, or y is equal to 2x plus 1. So that is the tangent line to the point P, or 1, 3, with that given equation. Okay, so now let's do problem 4. I'm going to skip the graphing part of problem 3. So we want to find the tangent line to the curve f of x equals x minus x to the third. And this is at the point 1, 0. And we're going to do the same thing, using the definition, using equation 1, and then finding the line. So let's just first use the definition. So we have the limit as x goes to 1 of f of x, so x minus x to the third, minus f of 1, which is 0, over x minus 1. Okay, so this is the same as the limit as x goes to 1 of negative x to the third minus x over x minus 1, which is equal to the limit as x goes to 1 of negative x times x squared minus 1 over x minus 1, which is equal to the limit as x goes to 1 of negative x, and then x plus 1, x minus 1 over x minus 1. These cancel. So we get, so plugging in a 1, we get a negative 1 plus 2, so this becomes negative 2. Okay, this is using the now using the equation, right? So we're going to have the limit as h goes to 0 of f of a plus h, which for us is going to be 1 plus h minus 1 plus h to the third, and then this is going to be minus 0, because minus f of a, which is 0, because we're at the point 1, 0, over h. So this is going to equal 1 plus h. So let's just see what 1 plus h to the third is. So 1 plus h times 1 plus h is equal to h squared plus 2h plus 1. Multiplying this by 1, let's just do h plus 1. This gives me h to the third plus 2h squared plus h squared plus 2h plus 1. So this becomes the limit as h goes to 0 of 1 minus h minus h to the third minus 2h squared minus h squared minus 2h minus 1. So these cancel, and then this is divided by h. We can take out an h, so this becomes the limit as h goes to 0 of h times negative 1 minus h squared minus 2h minus 1 minus h minus okay, 2h 2. Wait, sorry, this should be a plus h, because this is that, right? 1 plus h, that's a plus h, so this is a plus 1, okay, minus 1, okay, all over h. These cancel, and then this becomes, so as h goes to 0, this vanishes, and anything with an h vanishes, and then we get 1 minus 1, which is 0, minus 2, so that's negative 2. So we get the same exact solution. So we know that m equals 2. Okay, and now again, so now let's do part B. So our line, so we have 1, 0. So we're going to have y minus 0 is equal to 2 times x minus 1. In other words, y is equal to 2x minus 2, and that is going to be our line. I'm not sure, I wrote something and the app closed and now it's not here, so I'm going to just do part B again. So we have that our point is 1, 0. So we're going to have y minus 0, which is that, and then minus 2 times x minus 1. And this is going to make us y is negative 2x plus 2. So that is going to be our line. So now I'm going to look at problem 5, which is y equal f of x, or y is equal to x minus 1 over x minus 2. And we want to find the tangent line at the point 3, 2. So I am going to focus on the second method, because that's generally where everything eventually is, where everyone starts using. So we have the limit as h goes to 0 of f of a plus h minus f of a over h. In other words, we have the limit as h goes to 0 of, so a for us is 3. So 3 minus 3 plus h minus 1 over 3 plus h minus 2, that's this, minus f of a, which is just 3, sorry, f of a is 2, over h. So now this is going to equal, okay, so the limit as h goes to 0 of h plus 2 over h plus 1 minus 2, what we want, so let's do minus 2 times h plus 1, right? And then over all of this, over h, but because we know that a over b over c over d is equal to a d over b c, we can take our h and just multiply it up here. Sorry, the h doesn't come here, the h comes here, right? Because this is the same as a, b over, and then we have h1, so the h and the b multiply, and the a just gets multiplied by 1. Okay. So now this is the same, this is equal to the limit as h goes to 0 of h plus 2 minus 2h minus 2 minus 2, so these cancel, and then you have h minus, so this becomes negative h up here, so you get a negative h over h plus 1 times h. The h's cancel, so this becomes a negative 1 over h plus 1, which when h goes to 0 becomes negative 1. So that is our slope. This is equal to m of our tangent line, and so we're dealing with the point 3, 2. M equals negative 1, so we have y minus 2 is equal to negative x minus 3, or y is equal to negative x plus 3 plus 2, or y is equal to negative x plus 5. This is the slope of our tangent line. Okay, so now let's look at problem 6. So we have f of x is equal to x to the third minus 5x, and we're looking at the point negative 1, 3. So we are looking at the limit as h goes to 0 of f negative 1 plus h minus 3 over negative 1, over h, equal to the limit as h goes to 0 of 2 negative 1 plus h, yeah, everywhere you see an x, you just plug in a negative 1 plus h minus 5 negative 1 plus h over h. So we have h minus 1 times h minus 1 times h minus 1. So first this is equal to h squared minus 2h plus 1 multiplying by h minus 1. We get h to the third minus 2h squared plus an h minus h squared plus 2h minus 1. So that's what we have on top. So that over there is this, and then we're going to just multiply all this by 2 and then take minus this part, which is minus 1, which is plus 5 minus 5h. And okay, and we're going to divide all of this by h, and there should also be a negative 3 over here because of this negative 3 was supposed to be over here. Okay, wow, so actually let's try to work our way back. I don't want to go to a new page. So this is going to equal the limit as h goes to 0 of 2h to the third minus 6h squared plus 2h minus 2h squared plus 4h minus 2 plus 5. Okay, plus 5 minus 3 becomes 2 minus this 2, so those cancel, minus 5h. Okay, and all this is going to be over h. And now what I'm going to do is I'm going to erase this, and I'm going to continue. So this is the limit as h goes to 0. And then you're going to have h. We're going to take it on h, 2h squared minus 6h plus 2 minus 2h plus 4 minus 5 over h. These h's cancel, and then when we have 0, this vanishes, that vanishes, everything with an h vanishes, so we're going to get 2 plus 4, 6, so this is going to be 1. So the slope, so m is equal to 1. Now, what do we have? Negative 1, 3. So to find the tangent line, we're going to have y minus 3 is equal to x plus 1, or y is equal to x plus 4. That is our tangent line, and we're done. Next problem is problem okay, let's do problem 7, and that will be for all of these. I'm not going to do problem 8. So problem 7, again, we're going to have the limit as h goes to 0 of f. Okay, our points are 1, 1, 1, f of 1 plus h minus f of 1, which is 1 over h. Well, our equation, sorry, is the square root of x. So this is going to be the square root of 1 plus h minus 1 over h. So now we're going to multiply by the conjugate. Let's try it. So this is going to be 1 plus h plus 1 over square root of 1 plus h plus 1. So this gives us 1 plus h plus minus, and then minus 1, or in other words h on the top. So this becomes the limit as h goes to 0 of h over, and then we just have h times the square root of 1 plus h plus 1. These h's cancel, and as h goes to 0, this becomes 1 over 2. So our slope is 1 over 2, and then we're going to take the line, so it's going to be y minus 1 is equal to a half x minus 1, or in other words, y is equal to a half x minus a half plus 1, so plus a half. So now for question 9, we're asked to find the slope of the tangent to the curve f of x equals 3 plus 4x squared minus 2x squared at the point x equals a. So we're going to find the function as an answer, meaning we're just going to forget about plugging in a specific point, and we're going to find the generalization of all the tangent lines to any of the points, right? So this is going to be the limit as h goes to 0 of f. And now we're going to choose x plus h minus f of x. And we're doing this because we want the general. We don't want to plug in a specific a here and a specific a here. We just want to leave all of this in terms of x and get out a solution in terms of x. Or we can write this in terms of a for any a, but I'm just going to leave it at x. Well, so this is going to equal the limit as h goes to 0 of 3 plus 4. Everywhere we see an x, we're going to plug in an x plus h minus 2, and again we see an x, we plug in an x plus h minus, and now we're just going to write down what f of x is, 3 minus 4x squared plus 2x to the third, and all this is over h. Wow. Okay, so this is going to equal, so let's first find what this is. X plus h times x plus h is equal to x squared plus xh, so 2xh plus h squared. And then now let's, so this is for here, but now let's multiply it again by x plus h, so we know what this is. Okay, so this is equal to x to the third plus 2x squared h plus h squared x plus h x squared h plus 2xh squared plus h to the third. Okay, so now let's write what this is. So this is going to be the limit as, you know what, I'm going to write it up here. So we get this is equal to the limit as h goes to 0 of 3 plus, and I'm going to put in the 4 already, so 4x to the third plus 8 x squared h plus 4h squared, 4h, no, I'm not doing this correctly, because I forgot to keep, okay, let's do that again. What is h plus x plus h times x plus h? This is x squared plus 2xh plus h squared. Okay, so now let's write it. So this is 3 plus 4x squared plus 8xh plus 4h squared. Okay, and then this is going to be minus, and then we're going to deal with here, so 2, and I'm going to write now this out, 2x to the third minus 6x squared h minus 2h squared x minus 2 x squared h minus 4 x h squared minus h to the third. And now I'm going to add in this part. So we get minus 3 minus 4x squared plus 2h. So this and this cancel. Okay, so now let's erase this. So that's that limit. We're taking all of this and we're dividing it by h. So now, okay, let's see. So this and this are going to cancel. And what else? And finally, this and this are going to cancel. So this is going to equal to the limit, and now I'm going to take out an h while I write this. So h times 8x plus 4h minus 6x squared minus 2hx minus 2x squared minus 4xh minus h squared. That's it. All this over h. Now these h's cancel, and everywhere I have an h, as h goes to 0, we'll just get rid of that. So this is going to vanish, and that's going to vanish, and that's going to vanish. So this is going to equal, with the limit, 8x, sorry, okay, 8x minus 6x squared minus 2x squared. That's going to vanish. And sorry, this shouldn't be here because it was that, and there's an h. There should be an h here, and this should also vanish. So this should not be here. So I get 8x minus 6x squared. That is the solution. So let's write that down. F prime of x, meaning the function of the which always like track of the derivative, is 8x minus 6x squared. It's 8x minus 6x squared. And now we're asked to find the equations of the tangent lines at the points 1, 5, and the points 2, 3. Well, this is, we can just plug in so we can find f prime of 1, and that's going to give us the slope of the tangent line at 1. So that's just going to be 8 minus 6, so that's going to be 2. And then for the second one, so this is m at 1, and this is for m at 2, we're going to have f prime at 2 is equal to 16. So, yeah, 16 minus 4 times 6 is 24 is equal to negative 8. So now to find the line, so let's find the line at 1. So for the point 1, 5, the line is going to be y minus 5 is equal to 2 times x minus 1, or in other words, y is equal to 2x minus 2 plus 5, so plus 3. And then for the second point, 2, 3, so now the slope is negative 8, so our line is going to be y minus 3 is equal to negative 8 times x minus 2. In other words, y is equal to negative 8x, and then we're going to have plus 16, and then plus, so this is going to be plus 19. So that is going to be our line. Okay, next problem. I don't think I'll be able to finish this section in an hour, but I don't really want to make 2 videos for this section, so I might just go for 2 hours this video. Apologize for that, but I mean, I think it's important to get these intuitions in order that we understand what derivatives are. Okay, I'm going to do problem 10 now. So I have, one second, I have that f of x is equal to 1 over the square root of x, and we want to find the tangent point to any x equals any x equals a. I'm just going to keep it as x. So let's see. So we're going to have the limit as h goes to 0 of 1 over the square root of x plus h minus 1 over the square root of x over h. So this is going to equal square root of x minus square root of x plus h over the square root of x plus h times square root of x, all multiplied by h. Again, the reason is that this can be viewed as 1 over h, and then I found the common denominator, and then I just put the h up. But actually, I want to do this by conjugation, so I'm just going to keep the h down here for now, and then I'm going to multiply all of this by square root of x plus the square root of x plus h over the square root of x plus the square root of x plus h. So this is the limit as h goes to 0. This is equal to x. So this is equal to the limit as h goes to 0 of x plus, minus x minus h minus all over, so all over, so now I'm going to put up the h. I could have actually done this before. All over x plus h times square root of x times h times the square root of x, square root of x plus square root of x plus h. And now these cancel, and then the h's cancel. And then when I go to 0 with the h's, I'm going to get negative up here, -1 over, all the h's go to 0, so this becomes square root of x times the square root of x, which is x squared, so it's x squared, it's just x, it's x times square root of x plus the square root of x, so 2 square root of x. Or in other words, this is equal to -1 over 2 times x to the 3 over 2. Yeah. Okay, so that's what we got. F prime of x is equal to -1 over 2 times x to the 3 over 2. Right? Yeah. So now we're asked for 2 points. What are the points? One of them is 1, 1, and the other one is 4 and 1.5. So we want to find the slope at these points and then find the tangent line. So to find the slope, again, this is for any arbitrary x. So to find the slope for here, we're just going to plug in 1, and to find the slope for this point, we're going to plug in 4. So it's going to be f prime of 1 is equal to -1 over 2, just a half, and f prime of 4 is going to be equal to -1 over 2, and then, well, let's look at it in terms of what we knew before. So this is going to be 4, and then times 2, the square root of 4, which is 2. So this is going to be -1 over 4 over 16. So now when finding the lines, we're going to take y minus 1 is equal to a half of x minus 1. Solve for this, and y minus a half is equal to 16x minus 4, solve for this, and when we solve for this, I'm not going to actually do this, but we're going to get the lines. Next problem. So let's do problem 11, just so that we can get, well, I would have to draw it. Okay, I'm not going to draw these, so I'm not going to do those problems. I'm going to go on, but it's important to understand how the derivative of all of, okay, fine, I'm going to draw it just because it's important. The intuition for problem 11 and 13 is important, but I might just do a different problem later, like problem 17, and that will help with the intuition, because I'm not going to draw it now. So let's look at problem 13. So we are given that a ball is thrown into the air with a velocity of 40 feet per second, and this height in feet after t seconds is given by the equation f of t is equal to 40t minus 16t squared, and we want to know the velocity at t equals 2. So we throw the ball into the air, however the equation looks, I don't think too much about it, and we want to know at t equals 2 what's the velocity. So the velocity is how much, it's basically how much we're changing in the y direction in terms over x. So how quickly are we moving in the y direction in terms of, basically it's the slope. It's the slope of the tangent line at t equals 2. Because we're asking at y, how quickly are we, how quickly is the rise in terms of the run. So, right, because the t represents the time and f represents the movement, so we're asking how quickly are we moving in terms of time. That is what it means to have a velocity. So if we want to do this perfectly, what we have to do is we have to find the slope of the tangent line is at t equals 2, which we know how to do. This is the limit as h goes to 0 of 40 t plus h minus 16 t plus h squared minus 40t plus 16t squared all over h, right? That's how we find the slope, and this is how we find the slope at any t, and then we're just going to plug in t equals 2. We figured this out, so this is going to be equal to the limit as h goes to 0 of 40t plus 4th minus 6, no, so what is t plus h squared? So this is t squared plus 2th plus h squared, so minus t squared minus 2th minus h squared minus 40 minus 4t plus 16t squared, right? Yeah. So then this and this cancel, and 16t squared and 16t squared cancel, and we're dividing by h. So next step I'm going to take it at h, so this is going to be the limit as h goes to 0 of h times 40 minus 2t minus h over h, these cancel, and then this h goes to 0, so this becomes 2. When we open this up, we got this, and I put a 16 here, but I forgot to multiply this by 16, so this should really be minus 32, and this by 16, So this should be minus 16 over here. Anyways, this vanishes, but this over here should be minus 32. So this is equal to 40 minus 32t. This is the equation of all the tangent, the slopes of the tangent lines for any t. So now f prime of 2 is equal to 40 minus 32, and yeah. So this is the velocity, and our velocity is, I don't know, whatever it is. It's a negative number, so yeah. It's a negative number, which means that the ball is falling back down to the ground at a certain speed. So it's moving at a speed negative speed. So it's falling back down to the ground at this point at time 2. Okay. So the next problem that I'm doing is problem 14 on page 120. If a rock is thrown upwards on the planet Mars with a velocity of 10 meters per second, its height in meters after t seconds is given by the equation f of t equals 10t minus 1.86 t squared. So the first problem asks us to find the velocity of the rock after 1 second. So we want, so for t equals 1, we want to find the velocity of the rock. So again, we take the limit as h goes to 0 of 10, 1 plus h minus 1.86 1 plus h squared minus 10t, minus 10, and then minus 1.86 over h. So the question is, it's 1 plus h squared. So this is equal to h squared plus 2h plus 1. So this is equal to the limit as h goes to 0 of 10 plus 10h minus 1.86 h squared plus 2 times 1.86 h plus, so there's a minus here, so it's a minus, so this is a minus, and this is a minus, minus 1.86 minus 10, so these cancel, minus 1.86, sorry, there's a minus here, so this should be a plus, so this should be a plus, so okay, so these cancel now. Taking this and dividing by h, so now this is equal to the limit as h goes to 0, take out an h, 10 minus 1.86 h, right, minus 2 times 1.86, okay, over h. The h's cancel, the limit gets rid of this, so this is going to equal to 10 minus 2 times 1.86, so this is our velocity. So this is equal to m. So then the second question asks, find the velocity of the rock when t equals a, some arbitrary a, and so we would have to do all of this again, but we would follow basically the same strategy. When will the rock... Okay, so let's actually do it, because in order to answer the next couple of questions, we actually need to know. So I'm going to do this again. I should have done it for any arbitrary one to begin with. So again, we have f of t equals 10t minus 1.86 t squared. And so now we're taking the limit as h goes to 0 of 10 t plus h minus 1.86 of t plus h squared minus 10t minus 1.86 t squared all over h. So now we know t plus h squared is equal to t squared plus 2th plus h squared. So this over here is equal to the limit as h goes to 0 of 10t plus 10h minus 1.68 times t squared minus 1.686. Which one is it? 1.86 times 2 times t times h minus 1.86 h squared. This should be a plus again. Minus 10t plus 1.86 t squared. These cancel. And these cancel, dividing by h. So now let's rewrite this and take out an h. So this is equal to the limit as h goes to 0 of h times 10, then over here minus 1.86 times 2 times t minus 1.86h all over h. These cancel, and as the h goes to 0, this is lost. So this is equal to 10 minus 1.862t. So now this is for t equals a. So for problem B, we can say, well, for a, we'll just plug in 10 minus 1.86 a times 2. That's going to be our answer. And this is f prime of t. So f prime of t is equal to 1.86 times 2 times t, negative, yes, negative, minus, plus 10. Right? Yeah, that's correct. So now the question is, when will the rock hit the surface? So the rock will hit the surface when f of t is equal, right? We know it's equal to 10t minus 1.86 t squared is equal to 0. The rock will hit the surface when we hit 0. And this is, let me see, is there a t there? Yeah. This is the same as t10, 1 minus 6t is equal to 0. So one solution to this is t is equal to 0. Well, that's when we begin. So we don't want this. So the second solution is when 10 minus 1.86 t is equal to 0. That's the second way that this becomes 0, right? And so this is the same as saying 1.86 t is equal to 10, where t is equal to 10 over 1.86. So at this time, the rock is going to hit the surface. So that's the solution to problem C. And now problem D asks, with what velocity will the rock hit the surface? Well, you take the velocity, right? We're trying to find the slope of the tangent line at the time when we hit the surface, which is exactly here. So you take f prime of 10 over 1.86. That's going to get you to negative 1.86 times 2 times 10 over 1.86. These are going to cancel. Plus 10. So the answer is going to be 2. It's going to be 20. The negative 20 plus 10 is negative 10. So the velocity at which you hit the surface is at negative 10 meters per second. So I'm at 65 minutes, and I still want to do a bunch of problems. These problems. So I'm going to stop here, start a new video, again using the definition of the derivative. Eventually we're going to learn rules for how to just find derivatives in a much faster way, but this is using the definition of the derivative. How can we say things about the function, about the velocity, or about the tangent lines of functions, going back to the definition of the derivative. So I hope that this was helpful.